Wonderful. Okay. Oh, okay. It's six now. Okay. We usually get some people wandering in late, but this is already very full, which makes me very happy. Okay. So we're going to start off today's combined Unity art workshop. We're going to start off. Oh, hello. Um, we're going to start off with Unity. I'll go for 1 hour. Then Lucy will take the second hour, and then y'all can learn about art. Just as a quick, like, getting a feel for the room, who here is an AET major? Okay. Uh, who's CS? Okay, about 50-50. Anybody, anything else like RTF? Yes. MBA. MBA, nice.
Electrical computer engineering.
Nice. That's cool. Okay. So we have decent variety here. Um, who here has never used Unity before? Okay. Who here has used Unity just only a little bit? Okay. Who here has like made a game? Okay, nice. Okay. That's also good variety. My goal with this is, as you might see from the title, is to just kind of give an introduction to Unity, but from the perspective of trying to understand how does a thing like Unity come into existence. Um, so my goal is like if you already have some experience with Unity, you'll understand some of the more fundamental aspects of it, just so that oftentimes it can feel like Unity's in control of you, and we want to be in control of Unity. And then if you are just completely new to Unity, then hopefully this will be a good solid foundation to where a lot of the tutorials and all of the sort of different information you'll see will kind of start to make sense. Um, what's my lifestyle on here? Oh yeah, I wanted to kind of go ahead and show y'all like what my plan is for the Unity workshops this semester. I will post the slides on Discord, so if you'll want to take a picture, you can take a picture. But this is kind of the schedule for this. So this doesn't include today's, but on the 23rd, we'll have our Texas Game Jam workshop. I'll talk a little bit about that actually during the Game Jam workshop. I would highly recommend. I think I've said this to a few people, but I honestly think like one weekend of just doing a game jam, you learn more than you just as many tutorials as you want to do. So personally, I think it's the best possible thing that you can do if you want to kind of get better at Unity, is to just throw yourself into the pain that is a game jam. Uh, then on October 7th, I'm going to do a basically like a platformer workshop. Platformers, I see that a lot of people like to make platformers, and I also really like platformers, so I think they're cool. They are finicky. Uh, there's a lot of very sort of small details that go into a platformer that I think deserve a lot of attention. And it's also kind of cool because it's one of those things where like you as a programmer get to kind of really influence how the game plays. So small different trade-offs that you make with how you decide to program a specific mechanic is going to have a big impact on just how the game feels from a creative standpoint as well. Same thing with horror games. When we think of horror games, this will be like our Halloween themed workshop. When people think of horror games, they typically think of mainly something aesthetic, but there's a lot we can do on the gameplay side of things to kind of influence that feeling of like a game being scary. So we'll talk about that from a programming perspective as well. And then we'll have one more game jam, not game jam, sorry, workshop in November, and that is just TBD. I'll kind of get a feel for what people want to learn, and we have a number of topics that we could pick from. Um, who here is like mainly an artist? Okay, who here is mainly like a programmer? Okay, so I actually only have a few artists. I have like this is like one of the few times where I have like the artists like hostage in a room where I can like pitch programming to them. But I think it is very much worth, even if you are mainly into art, to kind of get a feel for how the engine works. We have lots of speaker nights, and a lot of I think some of the coolest speakers that we have are the tech artists because they get that kind of combination of both fields is very cool. And a lot of the times when you're making art for a game, you kind of have to know how the underlying technology works. Um, so even if you are mainly interested in art, I definitely think that, getting to know Unity on a technical level is still very important. Um, so yeah, few sort of EADS announcements. All of these will be posted. Who here is not on the Discord server? If you are, yeah, you can scan this whenever. This will also be on. Actually, you need to be on the Discord server to see the slides, so you can just take a picture of this whenever. I'll also come back to it if you need it. Um, but yeah, we have all of these pages. Main one is the Discord. This is where we send out most of our communication. Okay, good. Dev Nights. Our first Dev Nights is tomorrow. So you can take the information you learned from here and then to show up to Dev Nights and be like, I know everything. Um, but yeah, this is also advertised on the Discord. Highly recommend doing this. This is new. What we're doing is a semester long project, and I think that's really cool. And I'm excited for how that turns out. We also have a mentorship program. Last I checked, we didn't get that many signups for the mentorship program. So if you are definitely whoever like raised their hand and said that they've made that they've made games before, definitely consider signing up for a mentorship, and for everyone else, consider signing up to be mentored. Um, I think this could also be a really cool opportunity. And then finally, Texas Game Jam. Uh, Again, I'll talk more about this in the actual Game Jam workshop, but super valuable experience. I know every time I've done it, I mean, you learn a lot from every Game Jam, but would highly recommend doing this. Don't worry if you don't have any experience. This is the best way to get experience. Um, I really can't think of a more like a better way to learn. Okay, so then those are all of my announcements. Okay, so we've all had, so most of y'all have at least touched Unity at some point. Who has like strong feelings about Unity? I know you were talking about that. Who here, you have strong feelings about Unity too? Are those feelings positive or are those feelings negative? You have positive, you have negative feelings about Unity. Okay. Does anyone else feel strongly? Yes.
Like I've used Unreal for like but for maybe every single time I see a tutorial, my brain just like explodes.
Really? Okay. So yeah, that's really interesting because I'm in game programming paradigms right now and they teach Unreal. And I'm confused. I have no idea what's going on. Unreal is very confusing to me. Yeah, I think a big part of I guess it's easy to see like programming in general sometimes is like trying to get to the right answer. But I think what I hope to kind of communicate is that oftentimes things like the decisions you make in programming are just a result of like weighing trade-offs against each other. Um, so really any idea could probably work, and somebody has probably tried it, right? So it's less about I think what I want to encourage is when you have an idea, just think about the trade-offs of why that happens. Because, like, if I were to make a game jam, I would probably take a game engine, sorry, I would probably take a lot of different decisions to the what the Unity developers took. And if you were to make a game engine, you would probably take a lot of different decisions to me or to anyone else, right? So oftentimes the software we write is just a it's a compromise between a lot of different um, competing advantages and disadvantages. And so you might say that, oh, Unity is really good for this thing, but it's really bad for this other thing, right? Somebody somewhere decided that that was a worthwhile trade-off, and then we all just kind of live with the decision. And that's the case with all of software. So what I kind of want to do is start to think about how does Unity work and why were some of those decisions taken? And then so hopefully you'll have I guess, a stronger grasp of why we structure things the way we do when we're working in Unity. Okay, so first off, I want to start by talking about kind of what a game engine is. Who has like a good working definition of a game engine? Yes?
Things
Mhm.
to, to build games using UI and easier things than just what they're like building something.
Yeah, that's good. So, use the word abstraction. Um, to some of the non-CS majors, abstraction is a word that we use a lot. So I can explain this like okay, did we always have game engines? No, right? How were like how was Super Mario made? Like the original NES Super Mario. Yes. Yes. They sat down and then they wrote a lot of assembly. Who here has written assembly before? Would you like to write a game in it? They're all shaking their heads because no, you would not want to write a game in it. I have had the displeasure of trying to write a game in assembly. It is not fun. For those of you who don't know, assembly is like as as close to what the actual hardware is doing as you can get with like a human readable language, right? So it's not fun to write in. That's why we invented higher level languages like C++ and C Sharp so that we wouldn't have to deal with that. And on a similar line, that's why we invented game engines, right? So these first games had to do everything themselves. Uh, but then we decided that there are sort of commonalities between games. There are things that different games have similar, just similar components. And then so we decide, hey, there should be a tool that kind of takes all these things that are similar and then packages it up, and then everybody can use it without having to reinvent the wheel. So that's the purpose of a game engine, is to give you the systems that are sort of common to all games. And then what you have to do is just implement what is unique to the actual game, right? So that's a little bit vague. So let's start off by thinking about something like Pong. Does everyone know how Pong works? More or less, yeah. So like if I like snapped my fingers and there were no game engines, you just had a computer and then like a blank screen where you have to write all the code yourself. What sort of things would you have to invent to make something like Pong? Yes. Rendering, yeah. So like even more basic than that, we need a screen, right? We need just a basic windowing system, yes. A gameplay loop. So by that do you mean like a frame?
Yeah.
Yeah. So we need frames, right? This is something we take for granted. This is not trivial at all, to have like frames in a game. But that's something that it's going to provide for you, right? What else? What do you do in Pong? Yes, in the back.
Player controls.
You need player controls, yeah. So you need some way of reading input, right? Right. Yeah, we have collision, so we need like physics. Okay. So these are all the things that you would have to invent. Yes. Yeah, so score. And then you would need to display the score as well, so you need UI, right? So some kind of score. So are all of these things unique to Pong? No, right? Every game has these. So eventually we made game engines to kind of give us these things out of the box so that we could work on top of them, right? So let's kind of start thinking about these one by one, and then we'll see kind of the series of decisions that were taken to get to like a system like Unity, right? So we'll first start off with a screen, right? Most games take place in like some physical space, right? So we need a way to represent that physical space. So what we're gonna do is we're gonna come up with the concept of a scene, right? Right? And in its simplest form, our scene is just going to be just a 2D plane, right? It can also be a 3D plane, but we'll just stick to 2D plane, right? So we're gonna have just a 2D plane as our scene, right? And then so this is what we're going to call a scene. And all it's going to do is just store information about space, okay? And then we need to have things that go inside of our scene. So what goes inside of like Pong, right? What kind of things would go inside of our scene?
Score.
Yeah, we have score. Yeah. What did?
Um,
So we have the paddles. We have the ball, and then we have, of course, the UI. UI is kind of going to be a little bit separate. We're kind of going to think of it as being kind of more on top of the game. Sometimes games will do UI that's like part of the world, but we can think about that a little bit differently. But we'll focus on the paddles and the ball, right? So these are what we're going to call objects, right? They're the things that are physically inside, the scene, that have some kind of physical presence. And so objects are going to be things inside of our scene. So currently our system looks like this. We have scenes, and we have scenes that contain objects inside of them. Okay, but how do we differentiate the objects from each other, right? So like, I want to make a paddle, right? What sorts of things does a paddle need to do? Yes, a paddle needs to move, yeah. So a paddle needs to move, and what does it move based off of? Yeah, it moves based off of input. So our paddle object has input, and it has some way of moving, right? I'm also going to add on to this that this has some position inside the scene, right? So we need to know where it is. In fact, all of these are going to have position, right? So if we're thinking about a ball, how does the ball move? Just by itself, right? The ball needs to collide with things, right? So we're also going to have our collision system. Our collision system inside the ball. And are both paddles the same? If you have a single player Pong, do both paddles behave the same way? No, right? Because one of them is the one you control and the other one is AI, right? So we're also going to have these two paddles can also have different things, right? So really we have paddle 1, which reads input, and then paddle 2, which has sort of AI controlled movement, but it still has similar things, right? It still has a collision system, and it still has to move, right? Y'all are gonna have to forgive my bad handwriting with the mouse, but hopefully I'm speaking enough to where it still makes sense. So we have two different kinds of pedals as well, right? But are there commonalities between the pedals? Right? They're like mostly similar. They're just different in that very like inconvenient way that one has to be controlled by the player and then the other has to be controlled by the computer, right? So we've already kind of run into kind of a difficult decision we have to make, right? Programmers are lazy people, right? We want to do as little as possible, right? So when we see things that are the same between two different things, our instinct is to not to repeat ourselves. So we want to reuse as much as possible, right? So who here is familiar with the concept of inheritance? Okay. Who here is not familiar with the concept of inheritance? Okay. So when we say inheritance, I'll talk about scripting in probably like the second half of the workshop. But for now, we just have to kind of understand that inheritance means that we can have some object, and then we can also have some other object that we say inherits some properties from it, right? So we can have like a generic paddle. We can have like a generic paddle. And then we can say, this has the things that are common to it. It has collision. It has, I also didn't mention this here. We also need to render it, right? So this has some shape, right? Because they're both the same shape, right? So we define these properties as part of like the generic paddle. And then we say, okay, well, then we're going to make two sort of derived paddles. And then we're going to have the player paddle, and the AI paddle, right? And then in the AI paddle, we'll say, okay, well, we'll have our computer controlled movement. So we'll write our AI code in here. And then in our player code, we'll like read input. Right? So in this way, we say, okay, all of the stuff that's common is saved in the generic paddle, and then we only do the stuff that we need specifically in the sort of derived paddles, the children paddles. Does that make a little bit of sense to the people who haven't studied inheritance yet? Okay. My question to y'all now is, do you like this idea? Does this seem reasonable? Right? My understanding is that this is basically what Unreal does, is you have different derived classes. And this is a perfectly reasonable way of doing things. In fact, many people have done this, right? Let me give you all one case where we might not want to do this. So let's say we're making a game and we have lots of sort of props, right? So we have props in our scene. We have so maybe a bushes, we have like grass, and then we have trees, right? So I make my little inheritance hierarchy here. right? And then we like explore the world and we fight different enemies. So I have my basic enemy class, and then maybe I have a ranged enemy that handles only ranged things, and then maybe we have like a melee enemy that goes and like tries to hit you or something, right? And then so we structure our scene this way, right? Does this kind of make sense to everyone? Yeah. What if I decide that I want in my game to have something that sits there like a tree, but when I get close to it, it like starts attacking me, right? So then do I have like an evil tree, right? So who is the parent of the evil tree? Is it both of them? Is it do we have to sort of reorganize this hierarchy to be different? It might be a little difficult to explain to without like actually going over if you haven't actually experienced inheritance like in code. But we really don't like this. We really don't like the idea of a child class inheriting from two parents, right? The intuition for this is basically there might be conflicts between the two parents, and we don't know who we should derive what from, right? So there are some languages that will outright ban doing multiple inheritance. Like the language just will not let you do this. C++ lets you do whatever the hell you want, so it will let you do this. But there are tons of edge cases that make this sort of thing really messy, right? So inheritance is great because we get to reuse a bunch of stuff, but we also run into pitfalls where um, sort of the categories get muddied. And if you've ever worked on a game, you know that things kind of change often, right? As you play test and as you iterate, you want to do different things, right? So what is Unity going to do? If we say Unity says we don't like this, which to be clear, Unity does allow some amount of inheritance, right? But it's not the default way of doing things. So how does Unity expect you to work through this problem of we have two paddles, they have kind of similar things, but they're different in small ways that are kind of pesky from a programming standpoint. What we're going to do is we're going to say that our objects are basically just containers. What do I mean by that? The objects are basically just boxes where you can put stuff into. And what we're going to put into these objects is components. Okay? So we're going to think of objects as nothing more than a container for components to go inside. Okay? And these components are going to be different pieces of functionality. So we're going to have a component for collision. We're going to have a component for rendering. And then we're going to have a component for AI. And then we're going to have a component for like the player controller. Player controller. So I go and I write all of these components separately, right? And what I do is when I'm populating my scene, when I'm putting stuff in my scene, I'm going to say that paddle 1 gets collision, rendering, and AI. And then I'm going to say paddle 2 gets the exact same thing, except it gets a player controller as well. So I'm reusing all my different components, and I'm just saying my objects are basically just a list of components that each of them have. Does that kind of make sense? Okay. Does anyone want, I guess, more explanation on this? Okay. So this is the way that Unity is going to sort of expect you to do things. Where we call this composition, basically. So we call this composition. General conventional wisdom says that if you can do composition, you should probably do composition for a variety of reasons. But in practice, any system is going to have a mix between both. So it's important to understand these two concepts. One is we're just having our objects as containers, and then we sort of we plug in whatever components we need. The other is we have an explicit parent-child relationship. Okay? So this is an example of how Unity would do things. And Unity, in fact, it has components for rendering sprites. It has components for detecting collisions. It has components for drawing to the screen, so like a sprite renderer, right? So that's the way that Unity is going to handle these things. Okay. So hopefully my Unity project loaded, and we can actually see more or less how this is going to look. So here's my scene. Remember I said that my scene is literally just a 2D plane, right? Which actually, spoiler alert, it's actually a 3D plane. They just hide the z-axis, so you don't have to think about it. But we can just treat it as a 2D plane. Okay. So I'm going to make a game object. I'm going to go create empty, right? Move this down, minimize this. And then I'm just going to call it game object, right? And you can see that this game object is just a container. By default, game objects have one component and one component only, which is the transform component. The transform component just stores positional information. So it stores position, rotation, scale, right? If I wanted to actually show something, I would go to add component, and then I would put sprite renderer. And then I would go and I would choose my sprite. And I'll just, do I have square? No, I have to go down here. And then so the sprite is going to come from the file system here, where you see the project. These are your files. So all of your code, all of your images, all of your animations, any sort of data that's stored just on disk, right? This is where your 100 gigabyte games come from, is from this folder. Just from all of your assets that are stored in there. So I'm going to go and I'm going to create, and Unity does have some default some default sprites for us. If I can find them, 2D sprites, square. So yay, we have a square, right? So I'm going to go in here and I'm going to select square. And then now when I play, we have an object that has two components. It has a position in space, which I can go and I can move around, and you'll see it sort of reflected there. And then it has a sprite renderer, which is going to control how the sprite is going to look. Okay, everyone following so far? Okay. So the next thing I want to talk about is, so we have kind of things like collision and rendering, which are sort of very generic, right? But is AI the same in every game? No, right? Is the player controller the same in every game? No, right? So these are things that you're kind of going to want the player to code themselves, right? So now we're going to think about scripts. In this model that Unity has, scripts are just components. They don't have to be components, strictly speaking, but 99% of the scripts you make will be components. What does that mean? It means that they can be attached to a game object, right? So we're thinking of scripts very similarly to the way we would think about any sort of collision detection or any sort of a rendering system. We're going to think about it as just a thing that we're going to add onto here. We're going to add it onto this list as just a thing that gives the game object some extra functionality. Okay. So we'll eventually sort of add a script there. But I think it'd be helpful now to give some like background on how I guess this is going to work from a code perspective. So, who here can explain to me what an object is? Not as the way we've described it, as just like a container for components. That is what we're calling a game object. But what is an object from, I guess, from a programming perspective, from a strictly programming perspective? An instance of a class, right? So this is an instance of a class. Okay, who can guess what my next question is going to be?
What is a class?
What is a class? Okay. Let's be more specific. How does a class want you to organize code? Okay, so you have methods and variables. Okay. What is a method? Somebody else. Because I know y'all have used methods before, yes. Yeah. So, I guess in a slightly less technical thing, it's a thing that you do, right? This is some action, right? There is some action. What is a variable?
It's a class that stores data.
Does it have to be a class?
No,
If I say like int x equals 5.
no, it doesn't have to be a
Right.
class.
So this is a variable though. Like what would you like if methods are actions, then variables are they are definitely inputs to functions. Uh, it's information, right? It's some piece of data, right? Uh, so we can think of methods as like things that you do, and variables as data, right? So if we were going to make a person class, right? Uh, so we have our person class. What sort of variables might we have? We might have, like I don't know, name. We'll have age, right? So these are variables of a person. And then what are things that people do? They like walk, right? I think people walk, maybe. Uh, people sometimes eat too, right? So we have different methods for people. And then, so this is a class. Wait, and then what did we say an object was? We said an object was an instance of a class, right? So um, I can say that person Bob is equal to new person, right? And then I can say person Joe is equal to new person, right? And so what a class ends up being is basically a template for you to create specific instances of that specific instances of that class. So we have person as a class, just as a generic template for a person. And then we have instances where we say that sort of this is a specific person, or this is another specific person. And we consider those distinct from each other, right? So when we're making our paddles, right, we have sort of collision, right? We have a collider as a concept, right? Like collider 2D as a concept. This is internally, this would be represented as a class, right? That collider is going to store certain information, right? It's going to store sort of where am I in space? What are my boundaries? Am I a trigger or am I not a trigger? So by trigger, do you mean is this a thing that's going to interact with the physics system? So like if I bounce into something and then bounce off, or is this a thing that's just like, did I walk into this area, right? So we have different information. Actually, I'll go ahead and add a collider 2D. I'll do specifically a box collider 2D, and you can see all of the data, right? This is all of the public data of the class. This is all the things that are exposed to you for you to basically mess around with, right? So we have is trigger. We have size that we can change, right? So I can go and I can make this bigger on the x-axis, smaller on the x-axis. So I can go and edit sort of these specifically. So this is information. And then internally, Collider 2D is going to have some methods. So these are procedures. Like we said, these are things that the collider actually does. So like we'll have a function for, did I hit something, right? So these are all pieces of data and pieces of behavior that we've sort of combined into a thing called a class, right? So your scripts are going to be objects, right? Your scripts are going to be objects that you attach to this that are going to follow the very similar structure. You're going to have some data that you're going to store, and then you're going to have behaviors that react to those, right? Let me talk a little bit more about, first of all, does anyone have any questions? Okay. So let me talk a little bit more about specifically how a script is structured, okay? So we have our script. And we said the scripts are components, so they have data and they have some behaviors. Some behaviors that are common to every script are, we have start. Start means that when I create this object, right? So it's either I can create objects at runtime. So that means like in the middle of the game, I might spawn an object, right? So I might spawn a bullet if I'm like shooting a gun or something. I might spawn an enemy. I might spawn in a bunch of different props for a level, right? Or I might just have things loaded up as the game starts. So for example, this object is kind of already in the scene, right? when we started the game, right? So we have start. This is the first thing that happens. So you can have some code in here that's going to run on startup. Then we're going to pass to our update loop. Who can guess what happens during update? Yeah, so how often do we update? Yeah, whenever it wants. So we have some frame rate, right? So we have some frame rate where every frame we're just going to do whatever's an update, right? So let me go and add a script here. So I'm going to call this player controller because we'll build off of this a little bit. Player controller. So all I have to do is type the name and it'll create a script for me. And then it's going to take a million years to load. And then it's going to open up Visual Studio. Okay. And then we have our player controller. All that mono behavior means is that this script is a component. So once again, what did we mean by component? It's just a thing that you can attach to a game object. So that's all that mono behavior means. Right, so I'm going to get rid of these comments. So start, I'm going to basically just print hello. Hello. And then I'm going to come back. And then it's going to automatically compile my code. I'm going to come back. And then I'm going to press play again. And then we're going to go into the console. And we're not going to see anything because I haven't saved. Did I add it? No, I didn't add it. What a funny thing. Add player controller to that. Okay. Now we go. Hello, right? So it ran only once, right? So what would happen if I did something like this? So I'm going to say that we're going to have an int. So this is a piece of data that I'm defining. Int x equals 0. And then I'm going to say that x plus plus, this means take the current value of x and add 1 to it. And then I'm going to print x. What is this code going to do? Yeah, so you're just going to get like 1, 2, 3, 4, 5, 6, 7, right? All the way up, right? So I'm going to go and I'm going to run this. And you can see it's just going to start counting up, and it's going to start counting up by the frame rate. And then so this is running every frame. Okay? So this is the structure of a script. You have some stuff that you do to just kind of get set up, and then you have some stuff that you do every frame. And then you also have sort of event-based functions. So one, for example, would be like on collision enter. On collision enter is a function that can be called whenever sort of you collide with something, right? So these are event-based functions. Although update is also kind of an event-based function, right? It's actually all of these are event-based, right? Because one happens in the event that you start up, the other happens in the event that there's a new frame, and then the other happens in the event that you get collided, right? So all of this is basically just us reacting to events with some kind of behavior, right? I'm going to tell y'all like what 90% of coding in Unity is like. We have some state of the game. How do we represent state again? They're stored in components, right? So all of our state, does it kind of make sense what I mean by state? It's like there's just the state of our world. So like if you have all of your different things, they all store different data. So this is the state of our world, right? We have some state. We're going to read that state, right? So we're going to read it. We're going to take a decision based on that state. Based on that state. So like, for example, if I have an ability and I have a cooldown, right? I have some state that's the timer, right? The timer of my cooldown. I'm going to read whatever the current value of the timer is. And then if that timer has reached a certain value, then I'm going to go one way. If the timer has not reached a certain value, then I'm just going to do nothing, right? And then so you're going to update the state, right? So you're going to read some components data. You're going to have some like if this do this other thing, if some other thing do this other thing. And the other thing you're going to do is just update the state again for the next frame. So it's a big loop. It's what do I want the next state of my game to look like? Right? So to do that, we need ways to have our components to communicate with each other. Right? So who can explain the concept of a reference to a class or a reference to an object? Does it kind of make intuitive sense what I mean by a reference? Like if I have component A and then I have component B, right? If component A has a reference to component B, it knows how to access its data, right? So I'm here, right? And I decide that I really want to change the color of the of my square, right? I have to do that through code, right? Which means what component do I need a reference to if I want to change the color of my square?
Right.
Yeah, exactly. So luckily, Unity makes this very simple, right? So I need to store this. This reference, we're going to count it as a piece of data. So we're going to store that in a variable. So we're going to store a reference to sprite render. Sprite render, I'll just call it SR, right? So we're going to have some sprite renderer called SR. Now we need to go and actually get that sprite renderer. So I say get component, sprite renderer. And where do I want to store the sprite renderer? In SR. So I say SR equals get component sprite renderer. So get component is going to look inside of the object and it's going to just grab a reference to that component. And then now, what does it mean to have a reference? It means I have access to its data, right? So I'm going to maybe do something silly. I'm going to say sprite.color is equal to new color. Is equal to new color. And we can just give an RGB value. So I'm going to go random dot range 0. I always forget because some systems do 255, some systems do 0 to 1. Hopefully it's 255. We'll figure it out soon enough if it is like that or not. Another thing about programming to all of the sort of non-CS majors, we Google all of the time. I I have nothing memorized. The only thing I've ever memorized is just from doing it so often that it just kind of becomes second nature. So definitely don't feel bad for like having to look things up. See, that didn't do anything. Range 1, maybe? Maybe if I go floats. If this fails, there's definitely a way to do this. But if not, we'll just make it red. We'll be boring. Oh, that worked. Okay, so it is 0 to 1. Yeah. So okay, hopefully everyone I didn't give an epilepsy warning. I didn't think about that. Hopefully everyone's okay. But yeah, so what did we do there? We got a reference to the sprite render, and then we read from that component and we decided we're just gonna mess around with it, right? So this is basically all of the stuff you're going to do. When you're coding, you're just going to take some decision. In this case, the decision is just make it a random color. I could easily go in here and say like if input dot get key down key code dot space if I'm holding down the space bar, then sr dot color is equal to color dot like red or something. Otherwise sr dot color is equals color dot green, right? And then we'll just get rid of this. And then so it's green. Why is it green? Oh, get button down. It should actually be get key. That means if I'm continuously holding down the spacebar. Before it was only flipping one frame because there's one event when you do key down. But now when I go and change this, hopefully we'll go in here and I'm holding it down and we do this, right? So this is at a high level what like 90% of your coding is going to look like, right? If I want a reference to, so this is a reference to components that are inside my object, right? If I want a reference to an object that's outside, so that's actually in the scene itself, I can do that a number of ways. You can tag objects in Unity, and then so I can say that game object object is equal to, say, game object dot find. You can find it by its name, which I don't recommend doing that because it's going to have to search for your entire scene. Another way of doing this is find game object with tag. Right, and then I might have a tag that says like ground, right? If I want to reference to like the component to the object of the ground I'm standing on, right? Which we haven't actually made this tag, but you could make a tag like this. Actually, I'll show you very quickly. You can go in here, and then you see where it's untagged. You can just go add tag, and you can tag game objects with whatever you want. So that's a way of sort of discovering objects that are outside of yourself, right? So these are all different ways of just grabbing references, but the goal is still the same, right? So now that I have my object, I can go o.getComponent, and then I can like get its sprite render, or I can do whatever I want with it, right? Does that kind of make sense to everyone? Yeah? Okay. Let's see. We have about 15 minutes left, so what should I talk about next? I'll talk about fixed update next, because that's kind of wonky. Who here has used fixed update in Unity? Yes? Who wants to explain it?
I still don't understand.
Okay.
So, it runs one second frame that cause problems if your applicant monitors with frame rates.
Mhm.
What fixed update does, it's literally a fixed update. It runs every physics code that you could set in your settings.
Okay. Yeah,
So that consistent updates and that is frame.
that's true. Yeah. So that's exactly correct. I'm gonna be honest, I don't understand fixed update. I I think the only person to understand fixed update is the Unity engineers. The more you go into it, the more wonky it gets. But that's all like under the hood stuff. What fixed update is, the problem that fixed update is trying to solve is basically it's exactly what you explained. It's a thing that runs exactly 50 frames per second. Independent, but also not really independent. You can treat it as being independent of the main update loop. So what do I mean by this? So I can also go in here and go void fixed update. And these will sort of run, update runs as fast as it can, basically, just based on whatever the frame rate of your game is. Fixed update will run fixed 50 frames per second, right? Or at least it's going to try to, right? So that's the goal of fixed update, yes.
150.
Good question. You can change it. You can change it, yeah. They decided, some guy decided. It's just a good general number. Who thinks this is stupid and needlessly complicated? Yeah. All of you who are not raising your hands are lying. It's confusing. We're doing this to solve a very inconvenient problem that we have with specifically physics simulations. Turns out, so frame rate can fluctuate a lot. Sometimes your computer's having a good day and it's like running really fast, but then, I don't know, you open a YouTube video in the background and then half your memory is being taken up by Unity and then the game decides to like drop to 30 frames a second, right? So frame rate is very unstable, right? Which for most things that's fine, right? Like for things like reading input, we're like, okay, do it as often as you can and we're fine. For things like physics, when the frame rate isn't stable, things explode. This is where you get like rubber banding and things teleporting through walls, and just most physics simulations really, really benefit from numerical stability, is what we call it. So different engines will have different solutions for this. I think Unreal does like the smart thing where it's like you run it on a separate thread and then you do like fancy substepping in math. Unity just says we're gonna have a special update loop that runs exactly 50 frames a second. And we're going to use that basically exclusively for physics calculations, right? So when should you use fixed update, right? Because this is all that really matters to us, right? Is what should you put in fixed update? What should you put in just regular update? I can tell you what the definitely wrong answer is to just do everything in fixed update. Because you're like, wow, 50 frames a second is pretty good. I'll just do everything there. Your game will explode. Because what happens is, if it cannot physically keep up with the 50 frames a second, your physics is going to start breaking down. It's just going to break the engine. You're going to get very hilarious bugs, and then your players will be mad at you, right? So if you can get away with putting it in update, put it in update. What needs to go in fixed update? Basically, any continuous. I don't know how to spell continuous. That's probably fine. Continuous physics updates. So, an example: reading input, update or fixed update. Update, yeah, because it's not has nothing to do with physics. Keeping track of a timer. Is it physics related? So fixed update is for specifically physicsing. Update can keep track of time just perfectly fine. And actually, we'll see. We'll talk later about time.delta time. That'll be the last thing we go over today. How about this? A jump. So I press the spacebar and I immediately change my velocity to just go up. Update or physics update? Yes. Actually, you can do it in fixed update. I recommend doing it in update. The reason is it's a one-off thing, right? So it's like numerical stability doesn't really apply there, right? Because it's a one-off update. So if you're only doing something once, right? Like I press a spacebar, I jump, and then I forget about it, right? If you're only doing something once, I recommend just putting that in update, right? How about this? We have a player and we want them to accelerate, so we need to every frame change the velocity of the player. Where would we put that? Fixed update, yeah. That is like the classic case of something you would put in fixed update. Anytime I am continuously updating. So if every frame I find myself wanting to update the physics component of an object, I'm going to want to do that in fixed update. And that is so anything like a continuous rotation, a continuous acceleration, a continuous sort of change in velocity, which I guess is the definition of change in velocity. Yes.
So for the jump,
Yes.
so you said the jump. So that would go there.
Mhm.
But what if there's underlying physics that's controlling like how does that work?
Yeah.
Fix them.
So internally, the physics engine is going to handle that. So all you would have to say is, we call physics components like rigid bodies in Unity. It's just what we say for something that's controlled by a physics engine. All you would have to say is say like object.velocity dot y, so the y component of velocity is going to equal 10, right? And then so that's an instantaneous change in velocity. And then so now that it's the job of the physics component to handle that. So the physics component reads, it says, oh, I have my velocity. This is how I need to update my player, right? So actually, I can go here, right? We can do a very quick demonstration here where I'll add a rigid body. I'll add a rigid body 2D, and you can see it starts floating up, right? Did I tell it to float up, or did the physics engine tell it to float up, right? It was entirely just the physics engine, right? So all I would have to do is if I add a rigid body, and then I'll stick this in here. And then I go up here and I run this. Here it's affected by gravity, so it just falls, right? So there's nothing going on in like, oh, it says ground is not defined because this is from an earlier example, but that's whatever. So I didn't tell it to continuously fall, right? The rigid body just knows it has some gravity and it's going to do that on its own, right? So does that kind of make sense? Yeah. So what we have to handle is when we specifically are updating some aspect of the rigid body every frame. So for example, if I have some input, right? So if I have some vector for move input, so vector2 input, and then I want to continuously set as the rigid body's velocity. So if I get component rigid body 2D dot velocity is equal to move input, or I called it input, right? So something like this, right? We're making continuous updates to the rigid body. Whereas something like a jump, you would just say velocity.y equals 10, and then you would just leave it, and then the physics engine takes care of the rest. Okay? So that's what fixed update is for. It perhaps seems a little bit silly and difficult to understand, but if you just view it from the perspective of we're trying to solve the problem of numerical stability when it comes to physics simulations. And that's all handled by the engine. You just have to know when to use it, and you just have to be careful to not overload it with too much stuff so that it can keep up. But if you follow that basic rule, you'll be fine with fixed update. We have about 5 minutes, so we'll take these last 5 minutes to kind of talk about time.delta time. Does anyone want to explain this one? Yes.
The amount of time.
Yes, exactly. Why is that useful to us? Yes. Yeah, exactly. So, to kind of illustrate the point a bit more, if I say we want to move 5 units per 5 units every frame, is that character going to move at a constant velocity? No. Why? Because frame rate is not stable, right? So on one set, we're going to move 5 units, but there's going to be 100 frames in a second, so it's just going to zoom across the screen. But if you're on a really slow computer, maybe you're only running 20 frames a second, and then you only kind of inch across, right? So what time.delta time is going to allow us to do is to get the real time between 2 different frames. So if I wanted to move across at constant velocity, right, I would have my velocity. I would say, how many units per second do I want to move? Right, so I would say I want to move 5 units per second. Right? And then every update, I would say that my position dot x, right, plus equals, this is not entirely syntactically correct, but it's the idea. We're going to move our velocity, and then we're going to multiply it by time.delta time. So what this means is, right, if there are, say, 0.1 seconds between frames, right, we're going to move forward that much velocity, so like 5 units times that actual real time. So this means that no matter what the frame rate is, right, I am guaranteed to move a total of 5 units in 1 second. Does that kind of make sense? So we use time.delta time when we want to account for the fact that frame rate is not constant, when we want to have things at sort of a constant real time, right? So multiplying by time.delta time is going to be something that's very commonly done, right? So if you ever, as you kind of get more experience, you get kind of a sense of when you need to use it or when you don't. If you ever have things like that are moving suspiciously fast, or if you ever have things that are kind of jittery, consider if you need to add a multiply by time.delta time. Or definitely don't do what I see some people do. And they say, oh, wow, my character's moving really fast. Maybe I just need to set velocity to 0.0001. And then that'll make it move at a reasonable speed. And just remember that this is a tool that you have access to. Any sort of constant speed, this will be useful. That's all the time that I have, but I want to encourage y'all to, if you have any questions, please put them in the Discord. There's a help channel. We have lots of channels on our Discord, but really just put them in any channel, and I can take a look at them. And yeah, I think one of my goals this semester is to have the help channels on the Discord be more active with just any random questions about Unity that y'all might have. Okay, but yeah. Thank y'all for coming, and I hope I will see y'all in the future Unity presentations. And then I'll post my slides on Discord. Yeah.